Alright guys, sorry I had to be out, but I wasn't feeling great, so let's go ahead and do today's lesson, quadratic functions in vertex form. Alright, so this is a lot of information here. I want you to pause the video and write it all down. And when you open it back up, we'll talk about this. So this is vertex form. It's another form of quadratic functions. We had standard form on Friday, vertex form today. It has its positives and negatives, and on the plus side, it's easier to find the vertex. Vertex is just h comma k, where h is the number that's in the parentheses with the x, and k is on the outside. The big thing to notice is this is x minus h, so that means you have to look at the sign and be very careful with the sign for these. Axis of symmetry is just the h value there. And then we talked about this on Friday, but if a is positive, it's going to be opening up, meaning a minimum value, and if it's negative, it's opening down, which means a maximum value. Now, one thing I didn't emphasize on Friday that I need to emphasize today, when we do minimum or maximum, we have to also state that it is a minimum or maximum value at a specific point. And this is just the y value of the vertex. Okay, so we're saying it's a minimum at and then k, a maximum at and then k. So I'll do a couple of examples here. After the first one, I want you to pause the video and work them. And then I will work them out myself. So this first one, we have x plus 3. So remember, this is x minus h. So that means to get a positive there, h would have to be negative. So this is negative 3. And then k is over here for negative 1. Axis of symmetry is just the x value of the vertex. So x equals negative 3. The a is negative, which means it's opening downwards. That means it's going to be a maximum. And remember, the new thing that I didn't cover on Friday that I should have, maximum at, and then the y value of the vertex. So at negative 1. Y-intercept is, this one's the part that's a little bit different. The y-intercept, it's not just going to all cancel out. We're actually going to have to plug it in and solve. So we have negative 2 times 0 plus 3 squared minus 1. So negative 2 times 9 minus 1. Negative 18 minus 1, which gives us negative 19. So we have y-intercept at 0, negative 19. Really ugly y-intercept there. So vertex at negative 3, negative 1. Axis of symmetry at negative 3. And y-intercept way down here at 0, negative 19. So we have this side of the parabola. We need the other side. So 0 is 1, 2, 3 away. So we're going to go 1, 2, 3 on this side. So negative 6, negative 19 is the other point. Oops, there we go. And so we go down that way. So there's our parabola. And then our domain and range are normal as always. So domain is going to be negative infinity to infinity. Range is negative infinity up to negative 1. And then a bracket, not a parentheses. Okay? So most of it, it's going to be very similar. It's just how we get the information that's going to be different. Let's look at another one. Let's look at this one. Go ahead and try this yourself, and then we'll look at it together. All right, welcome back. So vertex. In this case, the vertex is going, or the h of the vertex is going to be 0, because there's no parentheses, comma, negative 1. Axis of symmetry at x equals 0. The a is negative, so it's going to open down again. That makes it a maximum at, and then just the y value of the vertex, so at negative 1. Y-intercept, when we plug in 0, we get negative 1. So y-intercept at 0, negative 1. So we have 0, negative 1, and that's the only point we have. So this one is one I wanted to go over because it is a little different. We don't have 2 points, so we don't have a mirror point we can use. Instead, what we're going to do is we're going to plug in some x value and figure out what the point is, and then mirror that point. So an easy one is just this one right here. This is x equals 1. So we'll plug in 1 to the equation. So negative and then 1 squared minus 1. We get negative 1 minus 1, which is negative 2. So that means at positive 1, we're going to go down to negative 2. And now we have a point we can reflect to the other side. And there's our graph. Domain is still going to be negative infinity to infinity. Range is going to be negative infinity up to negative 1 with a bracket. Okay? All right. Try this one. All right, welcome back. Vertex, this time is going to be negative or positive 1. Remember, it's x minus h, so since it's still minus, our h is just going to be 1. Comma 0, because there's no k up here. Axis of symmetry is x equals 1. It opens up. That's going to be a minimum at 0. And a y-intercept of, well, when we plug in 0, we get 2 times 0 minus 1 squared. So 2 times negative 1 squared, so just 2. So we have 0 comma 2. So 1, 0, 0, 2. And then our reflection point would be the same point on the other side. So there's our parabola. Domain, negative infinity to infinity. Range, 0 to infinity. All right. Last type of problem we're going to look at are these right here. You're told what the vertex is and that it passes through this point, 311, and you want the equation of quadratic. Well, let's look at the equation of the quadratic. Equation of the quadratic is y equals a times x minus h squared plus k. We can find h and k from the vertex. So y equals a x minus 1 squared plus 3. The only thing we need is we need a. That's where this point comes in. It helps us find a. So we're going to plug in 3 for the x and 11 for the y, and then solve for k, or solve for a. So 11 equals a 3 minus 1 squared plus 3. We'll move the 3 to the other side. So we have 8 equals a times 3 minus 1 is 2. 2 squared is 4. And so a equals 2. Now we're not done when we just get a. We have to actually create the equation, the full equation. So y equals 2x minus 1 squared plus 3. And there's our final answer. Okay? All right. If you have any questions, please send me an email or talk to me tomorrow. Make sure you work on the worksheet. You'll have a great day.